Hello guys, and welcome back to MonLabo Linux channel. Today we're gonna be start talking about Terraform. We did the installation last time, but we never went through the explanation of it, what it means. I know there are probably a lot of videos there, but everyone has his own approach of starting a new topic. So I'm starting with this. So sorry. So Terraform is one of the products developed by HashiCorp. Okay, so it's the company behind the scene that has been bought by IBM. So Terraform itself is an open source infrastructure as code tool written in Go language, okay, and developed by that company HashiCorp. So it allows users to define and provision infrastructure resources such as virtual machine, networks, storage, containers, and other services as well, whether they are on cloud or on premises. And it does that by using a declarative configuration language called HashiCorp Configuration Language, abbreviated as HCL. Key features. So, some key features of Terraform are number one, infrastructure as code, or abbreviated as IAC, and version system version sorry VCS. Sorry, so this is VCS. Oh, sorry, what's going on here? Sorry. So this is supposed to be VCS. I made a mistake here. So version configuration system. Okay, a version control system. So that's version control system, which provides consistency. Okay, so when we say infrastructure as code, it means that you can have your whole infrastructure defined in an environment, and then you plan your whole infrastructure how you want it. You design it with maybe one of the tool like draw.io or Excalibur or whatever. Then when you design that, now you start programming your infrastructure, and then you can do that with infrastructure as code. So you code your infrastructure so that it can be reusable and is version control in the Terraform state file. Okay. All right. So let's continue. It has a declarative approach as well. Declarative approach in which is that method that is used, which is that approach that is used to declare your infrastructure within a file. Okay, so declarative approach means that you have a desired state which sits inside your file, and then you want that desired state to go to a specific environment and be and take life. I would say like that, take life. So if you need something like that, you need to have a declarative approach, and Terraform lets you do just that. This will allow, exactly like we said earlier, consistency, reliability as well, and yeah, consistency across different environments. So it is also cloud agnostic. So when we say Terraform is cloud agnostic, this just means that it doesn't belong to only one cloud or to its own cloud. So it can interact with any type of cloud that you see out there. Most of them. So it not only can interact with those cloud, and we will use the term multi-cloud, but it can also support on-premises environment with some extensible providers. So workflow for provisioning for provisioning and management in Terraform. So we have a workflow that we use, and usually when the way you start after installing the tool, you program, you use your draw IO to plan everything, and then when you start coding, after you finish the code, you have to initialize first the um, you have to initialize the environment. Okay, so when you initialize the environment, it's going to download different providers and modules if they are there as well, or probably if you want to upgrade, you can also upgrade some version of your providers in the meantime. So, and those providers are coming from a specific block called providers that we will see down below. And then you can format. I see a lot of people forgetting to do that sometimes. You can also format your Terraform, HCL code. Okay, HCL code, you can format it so that it goes. I mean, everything is strictly aligned according to the Terraform standard, Terraform standard. Then we have validate, where you push your code against validation to see if there is any inconsistency. And if there is any, it's going to warn you and say, hey, this is there is a problem at this state, at this place of the file. Then after you do all this, you can finally plan. Plan here will give you an overview of what will be created into what has been taken from the declarative file that you have, the declarative approach, and what will be in live in your infrastructure once you push it. But if you already did that before, it's just going to refresh the state, and then you are going to see if there are stuff that needs to be done or not. Then during the plan, it might tell you what exactly will be added, what will be modified, what will be destroyed. Then you have apply. So for the apply, this is where you are kind of like, okay, I'm okay with this overview, and I want to I want to be alive on my infrastructure. Then it is Terraform is going to go ahead and it's going to go ahead and create all the resources that you have declared into your TF state file, into your TF file. I mean, and finally destroy. So destroy, it's I mean, if you are just doing that for development purposes, it is entirely understandable that you can destroy after you are done. But usually in real environment, we don't destroy just like that. You might destroy resources maybe after I would say couple years. Yeah. So if you are developing, it's okay to destroy, but when you are, if you are not testing and you are developing something for the whole community or the whole company, I mean the whole company, all the teams, yeah, we will destroy only when we feel like, okay, we don't need this anymore, so we can decommission these resources, and then Terraform will go ahead, all the things that he has created is going to delete them one after another, and also by resolving dependencies on resources as well. But there are a few times where destroying the resources may not go well, and you have to intervene manually in order to do that. Probably it's because a resource is still used somewhere that it did not really have power to control the dependency over those resources. Then going to number 5 here, modularity and reusability. So when we say modularity and reusability, this is one of the core functionality of Terraform. Terraform can take all the resources that we need to create and compact them into a module. Now the module is just a whole set of all the things that you see here, for example, except module like data, Terraform, resource, provider, variable, output blocks, for example. It's where you define, you put some kind of standard. Is a way to put a standard so that that code can be reusable across different environments and different teams. So this will not only ensure that there is a standard, but also there is a strong consistency between different teams because you just go ahead, okay? You take a specific code. It's like, for example, you have a map of a house, okay? And then a plan of a house. So that plan is like a blueprint. So that's what a module is a blueprint. Now from that blueprint, you can build multiple houses based on that plan and make just few adjustments. For example, according to probably your client's needs. So this is exactly what module does. So then it has a usability which just comes to what I said, that different teams can use the same code with consistency across different environment. Number six, wide range of provider. Terraform is also very strong. It has a very broad community that are coming stronger with a lot of providers along with provisioners. But for some providers, I mean, when we talk about providers, we can, for example, name AWS, Google, Azure, Archive, Local, Template File, and many more. For provisioners, let's finish with providers. So providers allow you to call a specific provider, API provider, okay, and these are just companies or different community that build really amazing automation stuff behind the scene that you can use to interact with to suit your needs, okay. So now for provisioners are just uh, building blocks that are used to create to execute local scripts where we have, for example, local exec, or remote scripts where we have, for example, remote exec. For example, let me take an example. Let's say I'm using Google Cloud or AWS or any other cloud, and then I'm launching a compute instance or AWS EC2. Now, within the AWS EC2, I want to install maybe um, some startup script that will do some stuff for me. So I can very well do that uh, with Terraform using those local exec and remote exec. And there are also there. So when we talk about providers and provisioner, they are all called plugins because you just plug them into your file, into your, I mean, you just call them into your file, and then they allow your Terraform to be more and more powerful. Then we have another feature called Terraform Console. So Terraform Console is that environment which offers you a CLI to test some part of your configuration files. It's really amazing. You may try it if you want. But throughout the development of this Terraform series, we're going to go ahead and talk about it. Now, Terraform standard architecture. Terraform standard architecture. So when we talk about Terraform standard architecture, we are talking about some stuff related to how behind the scene those provider and provisioner works. So this is not mine. It's from Medium, so I don't have ownership on this. So here, for example, you can see that we have here some kind of diagram. And then, so here, when you execute, for example, when you put into your provider and Terraform block all the providers and their provider version, and you execute the code, what it does is it goes online, okay? It communicates with the online provider to do some stuff, maybe to call some libraries and some APIs and bring them, try to run them against your code. And then, according to how you define your code, for the provider provisioner, Terraform will parse the content of your file, and then once the file respect all the standard, all the Terraform standard, or the HCL configuration, or the HashiCorp configuration language standard, the if you have a state file, okay, not if you have, but it's going to create a state file. Now that state file can reside in many places. So you can put your state file into a local into your local gist. This is called local state file, and it's not advised to do that. Or you can, which is the recommended one, put it into a remote state, okay, into a remote location, and this will be called remote state. Now, when you have a remote state, you have different tools that are involved into this. For example, AWS S3, Google Storage, Google Cloud Storage, or Terraform Cloud itself, or Azure Block Storage. So this is the typical the typical architecture of Terraform. High level overview of Terraform main blocks. So Terraform has different blocks that allow you to perform different tasks. For example, we have data block. Data block are meant to read, okay? They are meant to read what already exists within your infrastructure. They cannot, they are not there to create. For example, if I want to use the latest AMI on AWS, I have to use data, for example, and put some filter into it so that it can always pull for me the latest AMI, okay, and I'm going to use that within my code. So here, for the syntax, you have data, for example, then you have data type. So you have the data type, which most of the time will be same like the resource type. And then you have the local data name, okay, the local data name, which is just a random name that you create, but most of the time you have to align it with your resources that you are creating online, that you are creating, so that it makes sense to know what exactly you were doing there. Then we have the Terraform block. The Terraform block is usually where you start putting some configurations of your Terraform. For example, you can put the Terraform version that the code um, will be compatible with. Okay. For example, I cannot be writing a Terraform code with 0.14 and then I expect it to work very well with 1.12. So I might have some problem. Then you have also some Terraform, some provider version that you have to put there as well. Then you have resources. The resources, these are also one of the core functionality of an HCL file. Okay, so the resources usually they are meant to create stuff online. So this is meant, data is meant to read, and resource is meant to create resources online. Now, when you come to uh, how the block is read, So we have resource block, then we have the resource type, okay, which can be AWS S3 bucket or AWS. So it will mostly start with the name of the provider most of the time. Okay, most of the time we start with something like that. For example, Kubernetes underscore this, Google underscore this, or AWS underscore something. But now the local resource name is just how locally, when you read it for you, how does it make sense to you? So it means that that's a random name that you choose, but not only random, it has to be aligned with your workflow, what exactly you are doing. So you have to you have to um, compact that into a single name that makes sense to you. Then we have module. Module are those collections of configuration, okay, that are used as a standard or blueprint in order to recreate as many resources as we want, and they can be called by uh, by other module by other Terraform files as well, within different Terraform files as well. So for module, it has only one single block here where you have the desired module name. So you can put any module name there. Then inside here, the parentheses, you have to put the source and the version. So these are stuff that we are going to talk about later on. So it's just something for you to know how it is. Then the provider. So Terraform has different provider, like I said. So this is where you tell Terraform how to connect with a specific provider, or which provider to use in order to do something, because different provider provide different type of capability that you can use within your Terraform configuration file in order to interact with their APIs. So you can put, for example, AWS provider, archive, uh, file provider, the local provider, the template provider, Azure, Google, a lot. Okay, a lot. Kubernetes, Docker, and so many. Then variables. Variables here are just variables. So when we say variable, it means that something that can change as we want, for example. Okay. So something that can change in different environment, different stage. Okay. For example, when you want to create a variable, you put the variable, then you put a random variable name. But I will suggest you to keep it in line with the resource, with the resource block that you're interacting with. Okay. Sorry. With the yeah. So yeah. So we will see one example of this. So now you can also make Terraform read a specific your variable value, okay? Because within these parentheses, you can put a description, the type of resource that you want to, uh, the type of variable that you want for it. It can be Boolean, it can be a map of string, it can be string, it can be list, it can be a lot of stuff, objects. So over here, you can, if you leave that empty, for example, you can tell Terraform, hey, I want you to read this from my environment variable, from the OS environment variable, the operating system environment variable. And the way you do that, you type export and then space, you type tf underscore var underscore and then the name of your variable. So you see here, for example, I keep the same name. I kept the same name to say you have to put something. So this is standard tf underscore var, but the random variable underscore name here is just the name of your variable, how you name it. Then we have output. So output is just the desired information that you need to see on the screen when Terraform finish to apply or create your resources, so that it will pull those information from your provider, okay, and then give them to you without you moving the to the uh, to the console of the provider or wherever location you want to go to get that information. So if you don't understand anything right now, I don't expect you to understand it. I just want you to be aware of all this stuff, because when we restart, you will be like, whoa, 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 what is this? What is that? So I don't want you to get lost. Now, Terraform logs type. So Terraform has different logs. So the default is just info. Okay, the default is info, and that logs just give you information if something happened, what happened, or and so on. So if you want extend extend your Terraform logs so that you can see warnings, deprecation warnings, for example. You can see uh, maybe some stuff related to the life cycle creation, update, or deletion of your resources. Then you can put that to debug. Then you have trace, okay, which is it says here the most variables login level, providing step-by-step tracing of Terraform operations. This level is typically used for in-depth debugging and development purposes. So I'm gonna leave that to you, and you're gonna read the other ones. Okay. So, but now, how do you set those logs? So if you want to change your default logs, so you can say, okay, I don't want the default one that is tf underscore log equals to info. I want it to be tf underscore log equal to one error debug trace. Okay, one of the five. So if you are on a Unix-like operating system, you have to do export. If you are on a Windows command prompt, you have to do set. You have to type set. Okay, we are already at the end of this thing. So Terraform file extension now. So when you are going to develop your Terraform files, you're gonna have different extensions. So how do you read them? What do they mean? And a lot of stuff. There are some of them that I did not put here, but you may see most of them being something like this. So you have the .tf. This is the basic HCL file extension to write your infrastructure as code. So when you want to create a file, for example, if you want to create an EC2 instance, you can type that. You can say you type it, I mean, you create it by typing vim, or I don't know, whatever command, or if it's with the UI, but it will be ec2, for example, or machine dot tf. Okay, yeah. So now the tf dot json, which is just a variant of the HCL, but with a JSON type of declaration. Then we have the TF vars, which is the default, which is which will contain the default variables value if they were not provided when you declare variable, when you declare your variable. Okay, so if you did not provide that and you put all those variables here, just their name, not variable block again. So you put all their name into a file. For example, dev.tfvars if it's the dev environment, or prod.tfvar if it's the prod environment. So when you do that, sorry. So when you do that, Terraform will immediately go ahead and look into this file to see all the value for your variables. So if you don't have any file like this, or if you have a file like this, but you have put something like this, you have exported that variable, it's going to take this environment variable. This one will take precedent over the tf vars file, the .tf var file. Then we have the tf test HCL, which are the extension used for Terraform test file, which define tests for Terraform configurations. Then we have the TF state, which is the one where you can, which is the one created when when you apply your configurations. So it is created in order to have your local state or your remove state. Okay, so if you have a file that ends with tf state, just know that this is the Terraform managed state file. It's not a file that you manage on your own, it's a file that is managed by Terraform to version control different resources that it has created for you. So this file stores the state of your infrastructure managed by Terraform. It is crucial for Terraform to understand what resources it manages and their current configurations. Then we have the .tf plan. The .tf plan is a file that is generated by Terraform plan command. If you use Terraform plan command and you put dash output and then you do something like that, so it will contain the execution plan inside. Okay, so it will contain that. So instead of having that on the CLI output, you say, hey, I want to redirect all this into the file, and then that's how it is going to have all your plan redirected to a file. So this will have detailed information of the action Terraform will take to achieve the desired state. Okay, so let's see some examples of that. For example, if I was to come here, so you can see, for example, I have a provider here which is hosted on by which is signed by HashiCorp, and it's called Archive. Here I have different versions of it, or if you prefer, I will do something like this. So if you just type Terraform providers, you will get something like this, where you will have providers, you will have modules, you will have a policy library, and run task. So when you click on module, you will see all the modules that are available. We have up to 2277, for example, available as of now. Then you have the providers. So when you go to providers, you will see all these providers here. Okay, so here they tell you, for example, provider are logical abstraction of an upstream API. They are responsible for understanding API interaction and exposing resources. So here, for example, you have AWS, Azure, Google Cloud Platform, Kubernetes, Alibaba, Oracle Cloud Infrastructure, and many more. For example, I was touching on this. You have, for example, random, you have template that we talk about, you have time, you have a lot. So if I was to go to archive, for example, here I can see that I have a lot of informations. So here I have the provider HashiCorp and archive. Here is the version and the chronological development of these versions is displayed here as well. So now I can see here description about it and everything. Okay, Yeah, it has been there. It was published 3 months ago, and this is the source code, which is hosted on GitHub. So if you click on it, you will see that on GitHub, and the those different stuff are coming from here as well. Those information that you will have on Terraform, and here you will see how many downloads this week happened for this guy, how a month, a year, and the overall total of download. So, and then you will see other useful information here, useful links. So here you will see another, you will see those different tabs. On this tab here, use provider, for example. This is how you can use the provider, and this is at least the version with it, with what it is compatible when it comes to this version. So here is, for example, the Terraform block that we were talking about, where you can set up your required provider, your required providers, the version, the source, and also configure your remove state if available. Then you have the provider block here, which is archive, for example, because this archive right here is used right here. And then we have the source, which is HashiCorp/archive. So this one, HashiCorp/archive. And then its version, which is this one. So once you do that, you do Terraform init. That's what they are telling you here. And here you have overview of it, which was the default page. And finally, you have documentation. The documentation will provide you information as of the description to what this provider can do. Okay, and then on the right side here, you will see multi-language provider doc with Terraform, TypeScript, and Python. Yeah, because you can use your preferred programming language nowadays as well to start writing infrastructure as code as well, not only Terraform. And these are called CDK. Okay, they are called CDK when you start using them. So you can learn more here if you go with this. Then on this page is going to tell you the example usage schema that are part of this. So here is the provider itself, and here are the resource. So here is the one for resource block that we talk about. Okay, so you can see here it says generate an archive from content, a file or directory of files. And then you will see, for example, you have the resources. Okay, so the resource, we have those different keys and values that you will have, and then from those keys and values you can have attributes. Okay, you can have attributes that you can pull from there. So that's the thing. And then, for example, archive data, so you see that it starts with the same name as resource, archive underscore file, but the name here can be different if you want. It doesn't have to be the same. So now here it will be to read instead of generating something, so it will be there to read something for you. And then here they are going to put you what is required, what is kind of mandatory when you are using this resource. For example, they are going to tell you what is required, what is optional. Optional means that you can use or you cannot, you can decide to use them or not. And then you have brief description about what they do and how to use them, and in combination with which other stuff here that you can use. Then, so for example, here it tells you that you can generate file like zip file or tar.gz file, and here read only. for example, these are stuff that can be only read. Okay, read only attribute resource attribute. So you can only read from with this. And then nested schema, some extended other, some other extended stuff. All right, so if you allow me, I'm going to stop the recording here today. That was one of the longest video that I did since I started back with my YouTube channel. So if the information that I provided here today was really useful to you, then you know that we are going to start something really, really interesting. Please doing consider supporting the channel by doing this. And share.